Hello everyone and welcome to another video with Special Maths Academy. In this video, we'll be looking at the 24th problem from the Special Maths Contest 2023 first round. And it says, how many quadruples of positive integers d1, d2, d3, d4 are there such that d1 divides 5 factorial, d2 divides 5 factorial, d3 divides 5 factorial, d4 divides 5 factorial, and the GCD of d1, d2, d3, and d4 is equal to 1. Okay, so how do we solve this problem? First of all, we're going to define a set. So let AD, A sub D, okay, be the set such that we have these triples and, of course, that's condition D1 divides 5. So each of the triples divides 5 factorial. Okay, so for I equals to 1, 2, 3, 4. And D divides the GCD of D1, D2, D3, and D4. Okay, so for us to have this, we can also restate this as just A sub D equals to triple D1, D2, D3, D4, and D divides DI, which divides 5 factorial. Okay, so for I equals to 1, 2, 3, 4. Okay, so the reason why we can restate it like this is because if D divides the GCD of D1, D2, D3, and D4, it means D divides each of the terms in that GCD operator, which is, so D divides D1, D divides D2, D divides D3, and D divides D4. Okay, then something else we should take note of is, so if P and Q are distinct primes, so distinct prime numbers, then AP intersect AQ is equal to AP times Q. So A sub P intersect A sub Q is equal to A sub P times Q. Why? Because if you have some, so let's say we have some T, and P divides T, and Q also divides T, and P and Q are distinct prime numbers, that implies that P times Q divides T. Okay, so if we have that P must divide the GCD of the numbers and Q must divide the GCD of the numbers, then P times Q must divide the GCD of the numbers. Okay, so let's go straight to the question. Now, what's the question asking us for? It's asking us for is a situation where the GCD is equals to 1. Now, it means we want to look at situations where like nothing divides the GCD, of course, apart from 1. So to do that, let's look at, we have to consider A2, A3, and A5. Why do we have to consider this? Because we're talking about 5 factorial. The only prime numbers that divide 5 factorial are 2, 3, and 5. Okay, so we want to look at this set and look at how we can calculate it. But then for us to look at the case where the GCD is equals to 1, I want to consider the complement of this set. Okay, and in fact, what we are looking for is, so I'm just going to scroll it down a bit and write it. What we're looking for is A2 complement intersect A3 complement intersect A5 complement. Okay, so this is what we want. So then something else we want to look at is how do we find the size of set AD? Okay, the size of set AD. Okay. So to pick the set AD, given that D divides DI, which divides 5 factorial, for I equals to 1, 2, 3, and 4. For us to pick this set, we can consider, okay, how do we choose one term in this quadruple? For us to choose one term in the quadruple, remember, we want D to divide, so let's say D1, okay? And we want D1 to divide 5 factorial. So in fact, we can say like D1 is equals to some, let's call it D times some T. Okay. And we want DT to divide 5 factorial. Okay. So we want T to divide 5 factorial divided by D. Okay. So you want to find the number of T that satisfies this. And we do this. This is just for one operator. So it means, so just going to write an F statement here. Let tau of n denote the number of positive integer divisors of n. So this includes 1 and n as well. Okay, so tau of n is this. So it means AD, A sub D is equal to, so the size of this set, A sub D is equals to tau of 5 factorial divided by D. Okay, so raised to the power of 4. Okay, so why am I raising to the power of 4? Because uh, each of these terms in the quadruple can be picked independently, okay, through this procedure, and we'll apply the multiplication rule. So this raised to the power of 4. But first of all, what is tau of n? So if we have n to be, so we look at the prime factorization of n. If you have n to be p1 to the power of alpha 1 times p2 to the power of alpha 2, or so on and so forth, to pk to the power of alpha k, then tau of n is equals to 1 plus alpha 1 times 1 plus alpha 2. So just keep on adding 1 to the powers, multiplying it, 1 plus alpha k. Okay. So this is what tau 1 is equals to. Okay. So now let's dive to the problem. Now, before we go to the problem, we have complements, complements, complement, complement. Okay, so if we don't want 2 to divide the GCD, we don't want 3 to divide the GCD, we don't want 5 to divide the GCD. So something that comes to mind is De Morgan's law. Okay. So De Morgan's law is a good way to handle things with complements. See? I'm going to, highlight, I'm going to put some of these things I'm saying in the description for those who are interested in reading more about these topics. Okay, so De Morgan's law gives us that A2 complement intersect A3 complement intersect A5 complement is equal to A2 union A3 union A5 all complements. Okay. So that's nice. Now, for us to look at this complement, we want to think about what could the universal set be. Okay. So what could the universal set be? So the universal set is going to be A1. Why? Because 1 divides, basically every number. 1 divides GCD. So basically, we have that A2 is contained in A1, A3 is contained in A1, A4, A5 is contained in A1. Okay. Yeah. Okay. So now let's break this down. So here we can use so it means the size of this set. So the size of this set complement is just equals to A1 minus, so okay, I don't think I need the bracket again. So minus A2 union A3 union A5. Okay. So what next can we do? What next can be done? Okay, so something else we need to do, we need to apply inclusion exclusion principle. inclusion exclusion principle. So for those of you that have been following our YouTube videos, you should be used to this by now. Okay, inclusion exclusion principle to expand this term here. Okay, so we have this is going to be equal to, so let me just scroll down well. So this is going to be equal to A1 minus, so we have, let me just put the brackets. So it's A2 plus A3 plus A5, okay, minus A2 intersect A3 minus A3 intersects A5 minus A5 intersects A2 plus A2 intersects A3 intersects A5. Okay. Sorry about that. I'm doing small writing. A2 intersect A3 intersect A5. Okay. So recall that we said we can simplify A2 intersect A3, for example, is just going to be A6. So we can simplify this A1. We're just going to open the brackets and break this down. Plus A10 minus A30. Okay, so A1, so recall 5 factorial. Okay, so tau of A1, so I'm just going to do it. That's going to be tau of 5 factorial divided by 1, which is tau of 5 factorial is 5 times 3 times 2 to the power of 3. So that's going to be what 1 to the powers. So 1 plus 1, 2. 1 plus 1 again, 2, and then 3 plus 1, 4. So we have 2 times 2 squared times 4. So 2 squared times 4, all to the power of 4. Okay. Then for minus A2, so this is going to be, this power is going to be is going to reduce to 2. Okay. So the original is 5 times 3 times 2 to the power of 3. So for A2 to be 1 plus 1 times 2 times 2, then times 3. So we have 2 squared times 3 up to the power of 4. And then A3 is going to be, so this disappears. So that'll be 1 plus 1, 2. So 2 times 4 to the power of 4. Okay, so let me just confirm. 1 plus 1, okay. A5 is going to be the same thing. A6 is going to be, so A6 is going to be 5 times, so both 3 will disappear, and then we have just 5 times 2. So that'll be 1 plus 1, 2. So I have 2 times 2 plus 1, 3. Power of 4. A15 is going to be, so 5 is going to disappear. So it will be 3 times 2. So basically A15 is just going to be the same thing. A10 is going to be, so 5 will disappear, and then 2 will go down by 1. Sorry, A15 is going to be, so A15 is going to be, so 5 and 3 will disappear, so that will be 2 to the power of 3. So 3 plus 1, 4. 4 to the power of 4. A10 is going to be, so 5 will disappear, so we'll just be left with 3 times 2 will reduce by 1, so 3 times 2 to the power. So this is just going to be, so this is A10. So that'll be 2 times 3 power of 4. Okay. And then 830. So 830 is going to be, so 830, 5 and 3 will disappear, and 2 reduced by 1. Okay, so yeah, that's 3 to the power of 4. Okay, so now let's, break this down. So I'm just going to use a different color of pen. Okay. So now this first term simplifies. So 2 to the power of 2 times 4, which is also 2 to the power of 2. So that's 2 to the power of 4. All to the power of 4. That's going to be 2 to the power of 16. So let's look for other ones that only have powers of 2. So 2 times 4, that is 8. So that's 2 to the power of 3. Uh, all to the power of 4. That's going to be 2 to the power of 12. And same thing here. 2 to the power of 12. And then we have 4 to the power of 4. So that is 2 to the power of 2. So also that is just going to be plus 2 to the power of 8. And let's look at the ones that have 3 to the power of 4 in them. So I refactor out minus 3 to the power of 4. So this is going to be 2 to the power of 2 to the power of 4. And that is going to be, okay, so that's just going to be uh 2 times 4, that's 8. Okay, so this is going to be 8. And so we have 3 to the power of 4. So we just have 2 to the power of 4 here. We'll have 2 to the power of 4 here. And then we'll have plus 1 here. Okay, so let's scroll down a bit. So 2 to the power of 8 can factor out here. So that'll be left with 2 to the power of 8. Uh, 2 to the power of 12. So this will be minus 2 to the power of 4, minus 2 to the power of 4, and then plus 1. Okay. Okay, so this is going to be, so minus 2 to the power of 4 minus 2 to the power of 4, that's just basically minus 2 to the power of 4 times 2. That's minus 2 to the power of 5. So I'm just going to, factor that out. So I have 2 to the power of 8 minus 3 to the power of 4. And then we have 2 to the power of 8 minus 2 to the power of 5 plus 1. Okay. So 2 to the power of 8 is 256. 3 to the power of 4 is 81. So I have 256 minus 32. 2 to the power of 5 is 32 plus 1. Okay, so this is just going to be equals to 175. Okay. This is going to be 225. Okay. So this is equals to, so 175 is 7 times 25. 225 is 25 times 9. Yeah. Okay, so basically this is going to be equals to, so 25 is 5 to the power of 2, so we have 5 to the power of 4 times 7 times 3 to the power of 2, that is 9. So we have 3 to the power of 2 times 5 to the power of 4 times 7. Okay, so let's scroll up and see. 3 to the power of 2, 5 to the power of 4, 7. 3 to the power of 2, 5 to the power of 4, 7. That's option B. Okay, I hope you learned something new from this video. Don't forget to like, share, comment, and subscribe. And see you in the next video. Goodbye, guys.